Good day, guys. How are you doing today? Today we continue our lecture series from where we stop. Today we are looking at arrays, pointers, references, and vectors in OOP. Then we took how can we manage several objects in our object-oriented programming, especially in C++. Understanding how to handle groups of objects is fundamental to effective OOP. So now we're going to cover 4 of these. So arrays are like bunch of elements. It's an array are containerized container that can take more than one values at a time. Enables, but they are fixed. They cannot be, they are not dynamic. Unlike our vectors. A vector is dynamic. You can add as much as possible items to it, even that anyone at runtime as well. We can consider arrays to be tuple in Python, and we can also consider vectors to be list in Python. So list is dynamic in Python, while array also is constant, while tuple is constant also in Python. It's mutable. You cannot change it once declared. So also is array also in C++. In Java as well, we can be talking about array list. We have our normal array, we also have array list. As well, also have list itself as well. So now you also talk about pointer. Pointer enables to manipulate the memory. Dynamic and indirect memory access can get the address of a memory. You can point to the memory locations in C++. You can point to the memory. I talk more on pointers in our C programming playlist. This you can check the playlist. You see more about pointer there. Also talk about references. References is just what save as what alias. You are given aliases to also the same name. So you cannot take non-pointer, but pointer can take non-pointer. Can even point to another pointer, but you cannot have the references pointing to another references. No, pointer can still point to other references. You can also have arithmetic operations, functions, arithmetic, variable arithmetic using pointer. Let's see a sample of this example of this what we are covering today. Now we will use, for instance, let's have a smart home system. Let's use a smart home system to illustrate this. We have a smart light class, a class that is called a smart light. We need to manage multiple lights in a room. So we have a central controller for all devices. Then let's see an array of objects store multiple instances of the same class. We can have multiple instances of those classes, then in a contiguous block memory. Then ID for managing fixed number of similar entities. So they are already fixed. We have the number of lights that are already fixed. Maybe there are 4 in number, there are 5 in numbers, so they are already fixed. So now let's look at the scenario in a living room. A living room has a fixed set of 4 smart lights. An array is perfect for it. Why do we? Let me explain again. Array, for example, we have in a smart room, we have a constant light there. That is 4. And when it's fixed, it cannot change, cannot reduce from it. Understand? So then in the place that we have for dynamic light, or you don't know the number of lights, you can use vector to address kind of situations. Now let's see a sample of this smart light. Let's have a class. We have a class called smart light, as we said the other time. So if we also check our VS code, you'll be able to see it as well. We also have a class called a smart light here as well. Just demonstrating the code here. So we're able to see. Now let's come back. A smart light int number of brightness from 0 to 100. Let's have a constructor for it. It's public. Int also is brightness is public. Smart light is public. Then we are using initializer approach to assign value of brightness. This brightness will be equal to this bay, for you assign. Then we know what light is created. Once we instantiate this class and we run it, this method will be printed out. Light is created. Light object, smart light object is created. This place will be created automatically. Then display lights now. Display lights, display status is also public. It's found under it. Then we can also call this one as well through the help of the object we created. Then you can also look at the smart living room. In our main function, we also have what? We have a what? A smart living room. This is the end. This is the end of this class. So assume we have a main room now. We create an array of 4 elements. Understand? You can create array that's small. This is the first element. It's taking in 100. Unlike the other one before, we also have one class at a time. But here, this is how we create array. These are open braces and a close braces here. So just in our code as well, let me explain that to us. We have this. We have a smart light class. For example, let me collapse this. Then we have maybe smart light 2. Then we have private. We have public or brightness and brightness. We also have a public called smart light 2, taking in integer of b, for example bright. You can also do the same thing using this way approach, but not now. And then we have the full column, the brightness. Then we have it here. Let me edit. Then we have the smart light now. Display status here, called display. Sorry, display status is void display status, just void display status of brightness of this. Then we can easily call this. Then, for example, this way I'm going. Let me comment this one out. Then we can have array of smart. You know, before we can create smart light 2 and call it smart. For example, smart 2, and just assign a value of 10 to it, right? That is an array that take one class as an instance. But now we want to have like 4 of them or 5 of them. Smart light 2 of what? Smart 2, taking like 4 arrays of elements. The same thing as this, opening and end this with it. Then we have what? Smart light 2 that is taking in maybe 2000. Then you can see that we have 4 array here now. You can easily calculate the number of size of this array by just saying, okay, in length of this array, you can easily calculate the number of elements in case the array length is too high. So you can just use size of to get the first element, smart 2 of the first index. It can be any of the index. You can pick any. This is index 0, index 1, index 2, index 3. So with the first index, you can pick any of them to divide it to be able to get our what? Be able to get the length of that. You can say C out length of this. So you'll be able to get that. And also, then so that is how you can create an array object of a smart light. Now let's then continue our slide. Then we have 4 arrays of slide. We have 4 arrays here. You can easily call either of these items brightness.75. Then we have brightness. You can easily say this. What is it? You can easily put in a for loop here. I'm having a for loop here. For int days. Can you see? Each of these items will now have, sorry, automatic code completion is giving me error to make the code typing fast. All right, now you can see I loop throughout the length. This is the length it gives to you here. Then you can easily call this and display the result. You can run it now. If you run it, that is then let's see, brightness 10, 20 days. You can see we display them. We're able to loop throughout, passing the index, increment by 1, so to pass it, you move one after the other in the for loop, compared to doing it one after the other as we see it here. So you can see, be able to display the brightness, display the status as well, the output of the variable. Then, okay, now let's continue with a slide. Then we have now let's see the advantages and disadvantages of that. Advantage of using array: organized storage, fast direct access, compile time allocation. The memory is allocated at compile time. But disadvantage is that it's already fixed, just like tuple. It cannot grow or diminish once it's created. It requires constructor for if not initialized. We need to find a way of initializing it. Now let's look at vector. Vector is the opposite is the one that's what dynamic array enable us to pop elements in different enable us to populate, even diminish for me using. We go to one thing that is just required is include the include the header files, which is vector, and then we also have our std. We are good to go. Then std vector is a sequence container from C++ standard library that encapsulates dynamic size of array. Enable us. You can check this slide in the link below. I'm adding this slide in case I omit. Please, you can comment and let me add it. We want to add a new light to the kitchen without having to predefine maximum number. Maybe before you want to extend the light to other places, you can also as well include it there. Now let's see a sample of this. We have smart light. Let's see the code now. You can also modify it to make use of what? Include vector. After including the vector, which is required, then we have our normal code classes. Then we can have a functions, or we have what? A vector of this. This R is being created. For instance, to avoid this code to be different for you, maybe this one it looks somehow. I have a code created for testing simple with numbers. Maybe from there again you'll be able to get it. I have a test file here, test.cc. Can you see? Let's look at this array now. Can you see array of name, for instance? We have array of name. I declare it to be empty. You can pass something there and what? Push back. After we put the first one, it add the second one, it add the third one. So if you run this program now, let me try and compile. Test.cc. Can you see? I'm able to loop out throughout the whole element here. I'm having numbers 1, 2, 3. This is our normal array forms. This is normal array forms, but this is vector form. Understand? I can also, this is vector forms. So still leave these ones, I will explain them later. Then I was able to loop everything in that number. Maybe for example, let me come here. I also use this to loop through it and able to print out all the names. You can loop it through this method. This one here, this one is different. See one method here, which is different. This one is taking a list. This is like for each loop, either in JavaScript. Understand that it loops, that here is a container of elements. Then you each name here, you display them out. So this is a container, just print the names here directly without using an index-based, array index-based in this form. Then you can loop again the same way. This one ensure that it's true to the what? The data type. Why I just put auto here. Here I don't put auto, but here there is auto. Ensure that it's what? There is no any SS coding, SS code, and that is just precise what is needed is given. That's why you see auto included here. Then let's come back to our slides. Then let's come back to this vector now. You can see that vector can take in smart light, push back. It push to the next, the first element. That means it push to this, to the back. It will store, it won't come to the front of it. The next one will be hard to the back, hard to the back, hard to the back as it continues. So we can easily print out the same way, just like our array, but so we can also display the result. What are the advantages of this? The advantage is that dynamic size, it goes automatically. Manage its own memory, no manual or new delete is fine. Rich interface, size up, empty. There's some function you can call that what like size up. You can get the sets, you can clear, you can even empty, you can empty the whole array. can empty the whole array. For instance, if you can just clear this now. For instance, now let me clear. You can just clear this. You can just see out. See out what's the array names dot empty. Can you see? You empty this. See out no names dot empty. Then you can, if you now come here, see out names of dot size. Now I'm going to, it's going to give us 0. Let me include it here. Sorry. Then can empty the array back, of which you cannot do that in our, what is saying? It's returning a name string. Okay. Come. It said it's a function that returns a boolean. Everything with boolean. Good. Let's also check the result here. Saying let is 5. Good. I see. We are 0, showing indicating, but you still have array. I want us to empty this. If we empty, you can just empty or clear. Let's use clear. Name dot clear dot clear. Yeah. Let's use the clear. We have 0 now. And you see we have 0 here. We have 0 here. We have 0. So the thing is already clear. Nothing is in the list. So these are the functions you can also use with it. Slightly overhead compare is slower compared to normal array. Just a little bit slow, but reallocation can be costly, though infrequent. Then let's look at pointer now. Pointer enables to point to the memory address. It can be declared without pointing to anything for the first time. That will be null pointer. Then a pointer stores the memory address of an object in the memory. It stores you also have the direction operator or the asterisk. Use asterisk to indicate that we store something. As a pointer is able to store the address of variables. Just the same way we use asterisk. Use asterisk you have seen some code with asterisk. This enables dynamic memory allocation on the heap. Now we have the stack. Once you create a variable like this, int s is equal to this, int y equal to this, they are stored on the stack. All the things we are creating here, this one is stored on the what? On the stack here. But this is what is stored on the heap now. So here you can have more out of memory on the heap. Now we are able to what? Manipulate this same variable. We store the same thing. It got the address of this here. Now what it's doing here now? Once you use a pointer here, it firstly points to the first element, which is 2. Here. That's what it points to. It only pointed to 2. But we can also carry out a pointer arithmetic that enables us to point to the next item. How do we do that? We can also what? Add 1 to it. Understand? Can you see now? If we see this, we declare an array here. We declare a pointer here. But this pointer is pointing to the same, what is pointing to numbers. But mind you, it's not storing all these elements in this pointer. It's only storing the first element. So to get the next value in this pointer, you add +1 to it. That is how it's working. So now let's look at it here. Let's look at the way we can what? Let's loop through these arrays here. Number one is that you can also loop through it Numbers here, you use the pointer here, point to this I. When I is 1, when I is 2, when I is 3, so you point to this element, you get your result. Number 2 is that you can also what, since I told you the other time that it's pointing to the first element, then you now call it here with the reference operator. If you don't put the reference operator here, you are going to print, it's going to print out all the addresses for us. All the address for us here. If we don't put I've removed it now. You're going to see that. Let me run it back. It's going to print out all the addresses. Can you see? We'll get all the address on in the memory location. Instead of getting values like this, we're able to get what? The address. We use to point to the memory location. You store the address. You can say that the pointer is point to the address of this variable in the memory. Now, it's point to, since we increment it, and we increment it here, we have to increment it here. That is why it's able to point to the next one. Or else, it will point to the same memory. Let me also comment this one out. You see that it will print out the same thing. Then we have, now but you will be able to see that. Okay, you can see 0, 170, 170. Can you see the same address? In case you don't understand, let me now dereference it to get the value. To get the value. Can you see? It's only 2222222. I told you that time. You just store the value of the first element. But to increase it, what's going to what? I'm going to what? Add it here, point to the next one, point to the next item in the array. Then we have it here. You can see now we're able to get different values of it here. Now let's come back to our slide. When the number of objects is unknown at compile time, or when you need to manage the object differently, then you use the same what? Pointer classes. You can see a scenario controller manages various device light, thermostat, e.g. We use base class for that to handle them uniformly. Let's see the code here as well. We assume that we have a class already declared here. We have a destructor here of the device here for managing our resources. Then we create another class called a public that inherits the value of this from the device here. Then we have what? A controller that manages the device via pointer. We create a pointer. Can you see? They're the same way as integer or number values. We also create a class called device that also is a pointer. Main light here, new, because it's a pointer. We have to use new, not as ordinary. So remember, we also need to delete it at the end of this program. So we don't leave the memory unusable and we have to free resources. So this is pointer. So once you use that, this is stored on the heap with the new. But if it's in Java, you don't need this asterisk. That's the way you create objects in Java. Understand? The allocation is done on the heap. We get the value of 80, then we can easily access it. Imagine you also want to, if you are accessing, we write a pointer, you use this arrow sign that is dash and the greater than sign to invoke the display status. You can't use a dot operator, it will not work. Then you delete the memory as well. Then you can also see advantages of it. Enables for dynamic memory, support polymorphism, something can be appearing in many forms, but it's risky of memory leak and dangling pointers. So to avoid issue of this, you have to be able to know what you're doing when you're using them. Then let's see the disk pointer. The disk pointer is an implicit pointer to available in every non-static variable. Enable us to point the disk. I have a code there that points to, I think we use the disk. Let's talk about the disk method for disambiguation and method chaining. You can use the disk method for chaining two methods together or three as possible methods together that is declared with the instance of that class. Now we're going to see a sample of it for proper explanations. So this pointer is an implicit pointer available on every non-static member function. It points to the specific object in instance on which the function was called. What are these? These are the two things you see there. Disambiguation, method disambiguation, to avoid the use of having the same name. Maybe you are talking, okay, like byte that we allocate the other time, also having the same name with it. No, you can use this dot light to point to the member variable we now assign to the what? To the parameter allocated from the functions. Then we have return this. Okay, let's see disambiguation first. This is disambiguation now. This is the member variables here. This is what you use in Java to fact very well. I told you earlier also some video that both C, Java, C#, and C++, they have they are all emanated from C. So then we have just simple difference from within them. Then we have disambiguation now. What is disambiguation here? Ambiguity. Something appearing in many forms, appearing in many to avoid many multiple meaning. So we have brightness here. You also have brightness here. The same spelling. To avoid this disambiguation, so we can use this, and assign this, and assign the value of this into this. So this one is taken coming from the parameter. Some people just give it a different name, just as we did the other time. Then we also have method chaining. Method chaining return the this to allow sequential method calls on the same object. You can see be able to call different objects of the same different thing. So let's try to see it here. Can you see? We also have method chaining. It's taking the class name, used to create a method with a reference. We now create a function here. You can also have another function again of the same thing, but you will see it in action by the time we run the code. Let me show us the code. We have this code. Let me come to our first code there, which is app.sys. So we have this now. This is our previous code. Let me comment them out. We now unlock this. And just let me uncomment this. Let me minimize this so that we have a space. Then we have our smart. Let me open this now. We have the brightness. We have this ambiguation here. Right? Though I don't give it the same name, I just call it B. So, and we have smart pointer here to create a method. It's returning with this, a point with this. Let's see it in action here. What did he mean? What did he mean by that? Can you see that? I can even say, okay, let me call set mode. I call set mode twice. I can even call set mode again. Today I can use that same instance. Can you see? I can also use it to call the other one. But once I call the other one, I will be able to use to call it again. Set brightness. I can see set mode on just with the same something. And it also call set mode different places because we can't do that for set brightness because set brightness does not take a method chaining approach. It just declares our normal method. But this is our normal Our normal smart this is a method chaining approach. So you can just do that again. Set mode dark. Let's give it dark. And you can also call brightness and set mode. Can you see? You can use set mode. You are chaining multiple methods at the same time. Can I even still call the brightness as well? Now let's move on. This operator, so you can use this, you can see it. Also, let's talk about object reference now. A reference is just an alias for an existing object. It must be initialized. It cannot be make point when null pointer like the pointer. You cannot assign null pointer, null, L-U-L-L-P-T-R, null pointer to it, and cannot be reseated to refer to another object. It cannot be null. That is the preferred way to pass object to functions. To avoid costly is the preferred way to pass object to a function. Maybe you're going to pass an object to a function, you use the reference. You are referencing what is in this variable, something, this location. Don't just use to avoid the costly mistake of copying modification. Maybe a utility, in case a utility function to reboot any device, passing by references is efficient and guarantee the function receives a valid object. Then let's see an example of it. Can you see an example of it here? We have a function. We have this is the reference method. This is a reference symbol. Our passand. Then we're able to pass it and then use it here. Save alias, so you can see the difference between this and that. You can go through the differences for proper understanding. All right. For general guideline, prefer references when you can. use pointer when you must, that you don't have choice. When I'm pointing to a memory, use pointer. Someone to pass object to functions or other things, use references. For dynamic collections, use vector. And for raw, you don't want any addition or subtraction, use array. So thank you very much. This is the end of the lecture. So I will see you in the next one. Bye-bye.